This is my take on a power scraper. Rather than using an existing reciprocating tool like a lot of people have done, I did choose to scratch build the whole thing. I just found it to be just not really appropriate. You know, most Sawzalls or whatnot have a Scotch yoke that drives a little, you might call it a ram, but it's in a really sloppy slot, and it just doesn't have the precision that you need to scrape. So you'll notice throughout this that this looks a whole lot like a little mini shaper, which is really what I had in mind, was to build a mini shaper, something that was nice and rigid. You know, it doesn't need to be hardened. The ways can be scraped or re-scraped if need be. They can be adjusted with gibs in order to account for wear, and just seemed like an overall good system to do. I also had just made a dovetail cutter, so that worked out nicely. Here are all the parts for my power scraper. Right now I'm putting a little bit of Loctite on this bearing. Shouldn't actually be necessary as it gets compressed on the outer races and held in place, but I don't want anything sloppy here. There's 2 locator pins here that are holding this bearing plate onto what I'm calling the chassis, and then 4 632s here that hold it all in place. Now this bearing plate also carries the motor, and the end of it is tapped for 4 832s, and really precisely aligned, like worked quite a bit with a file in order to get just the right alignment on those gears. And I'm really cranking these down more than any of the other screws in this assembly, because this part's not coming apart. Okay, this is the variable cam and its various components. That's the jaw that slides through the slot here. Which way? Oh, that way. So, that all looks like. And then there's just 2 set screws here that the only modification is not necessary to make them a little bit shorter, and to make them very flat on the ends, because it's the top of that that needs to catch. And so the top of those set screws needs to catch on the slot that I've milled in the bottom of that moving jaw. Now that slot is only slightly longer than the length of those 2 set screws, which tends to make it a little bit tricky to move around, especially when I don't have it secured like I do right now. Much easier to do once it's in its bearing, or like I do here, I put it in a vise. And you'll see it's, you know, you got to keep it relatively in sync, but again, you have a thread or 2 of play there. And then when you're set out, you just I'll go ahead and lock that out there. It's good to go. Satisfying. Okay, so we've got a E-clip here. Keep that in place. After the E-clip, we have a shim that gets this gear to the right height so that it meshes properly with the pinion that comes into it. And then here's the upper shroud. This looks kind of shabby, but gets the job done, keeps the grease in place, keeps my fingers out of there, and it houses the electronics. It's held in place with the 2 screws you just saw me do. There's 2 more I'll do later on it. I think this is a tapered bevel gear. I'm not really sure. It came out of an angle grinder. It had a keyway drive on it, which I've replicated, and then it all gets drawn together with a center bolt under the shoulder there. There's the keyway. And we'll crank down that bolt. And that whole shaft is locked. I have another video that should go in here that shows the assembly of this. I'm not taking it apart again. It's just too much hassle. I have it. I took a video of it. I'm using some PTFE lubricant here on the shaft into the bronze bushing at the bottom. And then we just gotta press back the brushes here to get it to sit down onto the pads. Unfortunately, this can't be done after the housing is put over the top, which is tricky. That's what I'm about to do here. It's tricky because these magnets are pretty strong and they want to pull the whole shaft out of place and pinch your fingers and do all sorts of other stuff. So eventually I'll work that down into place and then get it going into the housing. Now this gear has to be in place when I put the shaft through it because it's a tapered gear and there's no way to re-engage it or get it engaged any other time. It's all very snug fit, including that registration. Just rotating it here in order to line up the bolts that hold it in place, and we'll crank those down. Inserting the keyway and struggling with a stupid little nut. See the little see the little keyway right there? That's a little bit stiff. Oh, no, it's the dovetail that's stiff. So this is set in epoxy underneath. All the components on the back side of this are potted in epoxy, and then on top of it is silicone. The idea being the epoxy is going to hopefully keep the connections from vibrating about, and the silicone is going to hopefully keep vibration from going in there at all. Also, it's going to be, I've potted the whole thing because I didn't want grease to get in there. I've also made, I had this the first time I assembled this, so I need to maybe modify this to work. Ooh, I got it pretty close. Better for something else. Blade that. But so far so good. I moved the switch to the side to adjust this thing. It's very convenient to lay this thing flat, and that switch was in a bad place for that. I put some standoffs and I mounted it to the board. That helped. I couldn't turn this before. I also kind of knurled it. I can do more with it, actually. It helped a lot, but I can do a little bit more. And I don't know why these aren't knurled. Everyone I've seen online is knurled. So that just fits right in there like that. Backtracking a little bit, we're getting the motor here attached to the chassis via those 4 832s that go into the end of the bearing block. I spent a great deal of time making sure this connection was square and gets those gears together properly. I really would have liked some registration or a set of locator pins to do it, but honestly I've had it apart 3 or 4 times and it seems to go back together every time with a pretty good mesh. Okay, let's just make sure we got a mesh there. That's looking pretty good. Alright, now it's time for some lubrication. I'm not exactly sure what was in this. Again, came out of an angle grinder. It was some pretty dark looking stuff, although that might have just been wear and tear on the gears. I'm using like a general duty wheel bearing grease. I'm just trying to get as much in there as possible. Make sure things are quiet and don't wear too badly. At the same time, I do want to keep my electronics, as free of grease and stuff as possible. That's not going to be good for them. So I'm trying to keep it all down low, and then I made this little splash shield that'll keep quite a bit of the grease down. It doesn't quite cover the whole gear setup. I could make a bigger shroud. Also would help if I could read the down sign there. And then the housing comes on the top like that. That aluminum shield is also a heat sink for the MOSFET that controls does the speed control for it. It's a simple 555 circuit in there with a 50K pot there on the side. I do really like the way the controls worked out. I mean, couldn't have planned it better, and I didn't really plan it, so that worked out nice. I've got 4 632s here on top. These are just computer screws threaded into the ABS housing there, and they seem to be plenty secure, even when that thing gets warm. Let's set that aside for a moment. So this is the spacer, which also functions as the other side of this. That's all. This is where most of my time was spent on this piece, which really, I'm pretty proud of that. So we got 2 locator pins. There's actually 4. I drilled 4 of them, but and then we've got I've rounded the corner over on this side to line all those up. And then we just have, I love that. Okay, now we're just getting all these mounting screws in. They're all 832s. The one side are a little bit shorter in order to prevent them from potentially interfering with the ram. I don't think they actually would have, but just as a precaution, I'm doing that. I'm not torquing these down terribly tight. I'm not torquing them down at all just yet. But even my final torque is just with that hand screwdriver. I don't really see the need for them to be too much tighter. Frankly, the thing could just about operate just with those pins shoved together on it. So now we're going some lubrication here. I've gone with bar oil. It's a very clear bar oil, so I think it's kind of, it might even be sulfur free. Okay, and here's the ram. Pretty. See how clear that is? There's probably better options than bar oil for lubrication here. I need to look into exactly how scraped ways work and what weights you need for different scraping patterns and things like that. But so far this has done a really nice job and doesn't seem to discolor, which means I'm not wearing too badly and really seems to do a nice job. Right now I'm adjusting the Gibbs screws here. Those are 632 set screws through the end, and then a second 632 set screw that is cross-drilled for that. That one has a nylon tip, and it basically just retains the first one. That's a pretty good system, especially I didn't want to have screws and stuff sticking out the side there. I'll do the final adjustment once that's all in place and powered, just basically based on how the motor bogs down. You know, I'll tighten up the gib and the motor will start to bog down. I'll back it off just a touch, and there you go. So we're getting the whole ram mounted here to the chassis. It's got 1 locator pin and then 4 counterboard 832s hold it in place. Makes it really easy to disassemble. I've got some other uses that I might have in mind for this ram, I think. Okay. So I have scraped these. I noticed on the last one that I pulled apart, these areas were very dark. Now some of that's because I got the bronze in there and that just is darker. But I also have scraped them on the last go around. Okay, just getting the connecting rod together here. As I was saying, it is scraped in order to try to hold some lubricant in there. For this, I've selected parts that you can just go get from Ace Hardware. It's 2 3/8" shoulder bolts, 2 3/8" bronze bushings, and then 2 3/8" bronze shims at the top. The shims just make up the space, the height difference. I couldn't get smaller shoulder bolts. But these are really the only wear items on this thing, and they're readily available at Ace Hardware or pretty much any hardware store. Okay, now I'm installing what is basically an oil retainer. There were some holes in the bottom of that housing from production that really let the oil just kind of leak out everywhere. So I don't know if this is the best solution, but it is holding it in. It's just a piece of Lexan. I made some tiny little 832s, and I just utilized the back side of the holes that already mount the whole thing together, so I didn't actually have to drill anything new. Just a thin piece of plastic under there, and it seems to be holding oil quite well. Okay, now we're getting the clamshell installed here on the top. This assembly was kind of destined for failure. This is the first time I've done it with the stroke length that's set to such a short stroke length. It's always been set more or less to its maximum before, which allows me access to these 4 screws that have to be put in place to mount the whole thing down. Now, I'm a pretty stubborn person, and I seem to think that I can maneuver this ram into a position that's going to get me access to that screw, and it just is not going to happen, no matter how I do it. So I do end up taking the connecting rod off here so I can have access to those. I could have just brought the stroke length back up, but now I can put those 2 screws, or those 4 screws in, and be good to go. I'm just adding the last 2 screws for the upper motor, or the gearbox housing there. Now, taking off that connecting rod was kind of it made some more problems for me. Part of the problem is that the shoulder bolt that goes into the cam there has a very flat bottom because there's not a lot of threads there, and so on and so forth. It has no taper in order to engage, so if I put the other side in first and then I try to engage that one, it will not go in. So eventually I figure that out, and I reverse the order that I'm installing them in, and I'm able to get the whole thing to go back into place nicely. Now we're installing the Lexan cover. Just made it clear so that I can see it for access to oil and to adjust my stroke length there. Now we're installing the foot, which I've modified to round over a lot of those edges to eliminate some of the pinch points that have been in there. There's a couple 632s that are pocketed in the front there that hold it on, and then a couple 832s in the back, and it's also pressed up against the edge. I've been using this one, so it's a little bit worn, but I like it, especially in this shaper. It's got roughly a 60 millimeter radius. Okie dokie. I like the way it sets, so if I need to make an adjustment to it, I can see in there. I've got access holes on the side here, and it sits really nicely in that position to make adjustments, whichever way I want to go. So maybe I should. I've already been scraping on this one. And I don't think, I think the tool actually works pretty nicely. I can't compare, I have nothing to compare it to, which is unfortunate because I suspect it's really mostly me not using the tool right. So I think to take the operator out of it here, because I don't really know what I'm doing. I think the only way to evaluate it is by consistency, and obviously the stroke length is incredible. You can see over here where this was the longer stroke length. This is the shorter, and I've crisscrossed, and that was better the way I've done that. Looks like I'm dragging still, but maybe that's okay. I'm kind of getting hung up on it. This wasn't even turned or anything. This is just a rotor. See that? Like there, I was way too close together, but that's kind of the stuff I want to use it for, is to almost, I don't imagine ever being able to flake with this, really. You know, that would be, but if I can get things, I've already been using it a little bit, and even on a bit of steel. Yeah, I mean, that's metal coming. I wasn't really digging in right away, but and a lot of people say they, you know, it slaps a lot when you start dealing with steel. I'm not seeing any of that. Honestly, it doesn't even. It really just taking material off of. I mean, I was working general highs and lows, but I wasn't looking for spots or anything. Not a lot of effort to go into it. It does slow it down a little bit when I engage, which honestly, quite frankly, I like it. I don't think I'd want it to be much faster. A couple things I'll note here. After the last couple fine tunings of that dovetail, I really took a lot of the deflection out of this. I haven't even tuned this jib right now. Jib, whatever. And it's really quite good. I wanted to focus any deflection, any spring that needs to be there, I wanted to be here. Which that might be part of it. I might want to thin this out a little bit. We'll see.